Okay, in this problem we have this link ABC, and it connects these two blocks A and B. And we're given that the velocity of A is 2 meters per second in the downward direction, and we're trying to figure out what this velocity of B is when this angle right here, is equal to 45 degrees. Okay, so how do we start? Well, we can start by using this equation we have for relative velocity. So the velocity equation is the velocity of B is equal to the velocity of A plus the angular velocity of this rod AB crossed with the position vector from B to A. So B with respect to A. So let's draw a kinematic diagram and put in everything we have. So here's this link ABC. Right here. Here's point A. And the velocity of A is going down at 2 meters per second. And the velocity of B, which is going to be right here, is going to be going to the right at some speed. And well, this example may seem sort of trivial that if this goes down, B has to go to the right, but in general, we're always going to assume a positive velocity or positive acceleration, and if we're wrong, and if the velocity is actually going this way, then our answer will just have a negative sign in front of it. So if we label everything we know here, so if we look at this, we have a velocity of B, and this is equal to a velocity of B with some I component because it's going in the horizontal. Our velocity of A is going to be equal to a minus 2j. This omega AB, well, we don't know what this is, so again, we are going to assume a positive angular velocity. And because it's positive, we're going to assume it's in the k direction. And this position vector of B with respect to A, since it's with respect to A, it starts at A and it goes to B. So this is our position vector, R of B with respect to A. And what is this? Well, we know that this distance from here to here is 0.2. This angle from here is 45. So our position vector from point B to point A is going to be this 0.2, this distance from A to B. It's going to be times this is going to be the sine, so the sine of 45i, and minus 0.2 times the cosine of 45j. Now, 45 is not always the best angle to use because if you mess up your sines and your cosines, you're still going to get the right answer. So it's good for the person doing the problem. It's not great if you're checking someone's comprehension of how to do a problem, but it's really not here or there. It's just sort of what it is. And now we can just put everything we know back into this equation. So if we put this in, we get VB with an I component is equal to this VA, which is minus 2 times a j component, plus this angular velocity, so W or omega AB of a k component, crossed with this position vector, which is 0.2 times the sine of 45 I minus 0.2 times the cosine of 45 j. And I hope that's all on the screen. I'll move over a little bit. So when we do this cross product, we're going to use this little trick with an I, j, and k. If we move this way, it's going to be a minus, and if we move this way, it's going to be a plus, sort of like our angular velocities. This way is our plus, this way is a minus, and this is how we can quickly do a cross product. So if we look at this, we get the velocity of B I is equal to minus 2j, just moving this over a little bit, plus, so let's look at this this cross product right here in a little bit more detail. And I'll do it over here just to keep things out of the way. So we're going to have a omega AB with a k component, and this is going to be crossed with this position vector, which is 0.2 times the sine of 45 minus 0.2 times the cosine of 45, and this is a j component and this is the I component. So we're going to take each of these terms separately. So we're going to look at this term crossed with this term, and when we do that, we have omega AB with a k component is crossed with this 0.2 times the sine of 45 of an I component. Our identities and what we know about cross products tell us we can bring this omega AB in this 0.2 times the sine of 45 out in front because they're just scalars. And when we do that, we get we'll get 0.2 times the sine of 45 omega AB with a k cross an I. And if we look at this little circle up here, if we have a k cross an I, we're going this way, so we're going to have a positive j. This is the k cross I is a j, and we're moving counterclockwise, so it's positive. So this becomes 0.2 times the sine of 45 omega AB j. Now let's take a look at our second term. So we're going to look at this term, we're going to look at this term and this term. So we're going to have a omega AB with a k crossed a 0.2 times the cosine of 45j. And again, we're going to take our scalars out in front, so we get 0.2 times the cosine of 45 omega AB with a k cross a j. Now a k cross a j, if we look at our circle, k cross a j is going this way. So to get from k to j, we have to go clockwise, and this is going to mean it's a negative. So it's going to be a negative I right here. And we're going to have a negative I times, this is going to be a minus 0.2, this minus sign right here. So this negative I is going to cancel out with this negative 0.2. And what we're left with is a positive 0.2 times the cosine of 45 omega AB with an I component. Now this is our answer for the cross product. And there's a plus sign in between. So we can just simply put this back into this equation. So we're going to have a 0.2 times the sine of 45 omega ABJ plus 0.2 times the cosine of 45 omega ABI. Now that we have this equation in terms of i's and j's, we can equate all our I components and equate all our j components. So I'm going to do my j components first because I know I don't have anything on this side. So this side of the equation, we're going to have a 0 is equal to a minus 2 plus 0.2 times the sine of 45 omega AB. And look at that, we can solve for omega AB. And our angular velocity of this bar AB is going to be equal to 14.1 radians per second. Now, it turns out our assumption was right because this is a positive 14.1, so it's moving in the counterclockwise direction. If we look at our I terms, we're going to have a VB, which is equal to, this term is a J, this term is a J, but this term is an I. So VB is equal to 0.2 times the cosine of 45 omega AB. And we just found that. We know that this omega AB is going to be 14.1. So when we evaluate this expression, we get that our velocity at B is going to be equal to 2 meters per second. And again, this is a positive 2 meters per second, so that means our block at B is going towards the right. And this is the answer we were looking for.